Hello everyone, I hope you're doing well. We're going to go ahead and continue on with our discussion over ocean movements. So there are three ways that oceans move. One is through currents, the second way is through waves, and the third way is through tides. Now I know you think that these are all the same thing, but as we look at each one of those, we'll see that they're vastly different and they're actually caused by different things. So not quite as the same as you thought they might be. So first, let's look at currents. And there are two types of currents. There are surface currents and subsurface currents. So obviously surface currents are on the surface of the ocean and they are driven mostly by wind. So as wind happens or as wind is created, it drags the water along due to friction with the surface. Warm and cold water get their temperatures because the surface of the ocean is in direct contact with the air above it. So if the air is cold, then the water on the surface is going to be cold. If the air is warm, then the water on the surface is going to be warm. So as wind moves the water carries with it the temperature of the region that it was from, and it can transfer either heat or cold to a new region of air. Subsurface currents then are currents below the surface. Sub, if you remember from Latin, it means below, so these are below the surface. And typically these are cold currents because surface temperatures can't go this far down into the ocean, so the water reaches a very constant temperature, but it's a cold temperature. And then currents here are typically driven by what's called density. And we've talked about density before. And if you remember, density is the amount of mass in a substance. So in the ocean, there can be water with a lot of salt in it and water with very little salt in it. And water with very little salt is going to have a low density versus water that has a lot of salt in it. So just like hot water will rise, remember we talked about hot air and hot air rises, low salt water is also going to rise. And then salt water that has a lot of salt in it, or high salt water, just like cold water and cold air, is going to sink. And so these two types of water, low and high density, can create currents or movement in the water. So okay, so in this video, you're going to be looking at temperature in water and how it behaves. So feel free, if your parents say it's okay, to try this experiment at home. It's easy enough, I think you can do. Little on the messy side, so that's why I say ask your parents first.
Hello boys and girls, and welcome to Hoopla Kids Lab, making science super fun and super simple. Today we're going to show you a wacky water experiment that I think is really clever. All you're going to need to conduct this experiment is a jar of cold water, a jar of hot water, some blue and red food dye, a plastic card, and a dish. Make sure that one of your parents is around to give you a hand with this experiment. The first step is to pour the red food dye into the hot water jar, and then very carefully stir it around to mix the colour. Then use some of the blue food dye to colour the cold water. This means you'll have a jar of cold blue water and a jar of hot red water. Make sure that the water goes all the way to the top of the jar so that it's almost spilling out. The first step is to put your cold water jar inside your dish, then carefully cover it with the plastic card. The next step is to turn this jar carefully upside down. You'll see that the vacuum formed inside the jar holds the card onto the surface. Then have your mum or dad place the hot jar of water into the dish and carefully place the cold jar on top. You'll need to go around every side of the jar and make sure that the edges line up perfectly. Then get someone to very carefully pull out the card from in between the jars. As they do, you'll see that the water starts to mix, which forms a pinkish purple colour. As each of the jars mixes in with the other one, you'll see that the colour evens out completely. This is because the water is very slowly mixing all of its molecules together. Now try this. Take the jar of red hot water, place the card on top, and repeat the same steps. This time the blue jar is on the bottom and the red jar is on the top. Have someone very carefully remove the card from the middle, and this time you'll see that the jars don't mix. So why is this? Is it the colours? No, it's not. In fact, the hot water has a different density to the cold water. It's very slightly less dense than the cold water and so sits on top. When we compare them side to side, you'll see that the reaction is completely different. This is because the cold water in the first experiment is more dense than the hot water and so sinks straight through all the gaps between the molecules in the hot water. And there we have it, a really simple, really cool science experiment. Show it to your friends and they'll have no idea how it works. Thanks for watching this one, boys and girls. Come back next time for more exciting science, subscribe to our channel on the link above, and leave any comments in the box below. See you soon. Hello.
So just like the cold water comes from cold air can come from cold water. Same with warm air and warm water. They can influence each other's temperatures, and that's exactly what an El Nino is. It is unseasonably warm water that warms the air above it, and that air moves over cool or cold land, usually in the winter, bringing unseasonably warm day in the wintertime. And those are the days that we all like to go outside and stand in the sun, and it feels so good. That's an El Nino. So there are actually 4 factors that can influence currents in the ocean. First we talked about is density or gravity. Gravity actually has to do with density because the more mass something has, the more gravity will pull on it. Second factor is the Coriolis effect. Remember that we've talked about the Coriolis effect before, and that if something's trying to move in a straight line across the globe, excuse me, the rotation of the Earth is going to have an effect on that movement. It's going to actually pull it to the side. The third factor is wind, and when wind occurs, it pulls on the surface of the water due to friction. We've already talked about that just a little bit. And so it moves those water molecules and creates a current. And then finally, heat energy from the sun. And of course, that then is either making hot water, which rises, or cold water, which sinks. And remember that I told you when warm air, or when air warms up, the molecules get further apart. It's kind of like we said in the summertime when you're outside and you're playing and you get really hot because the weather outside is like 102 degrees. You don't want your best friend hugging on you. You want everybody to go away because it's hot. And we said that water molecules and air molecules do the same thing. As water molecules heat up, they tend to move further and further away from each other. And that leaves room in between the water molecules for oxygen to move in and become part of the solution of water and oxygen together. So it's kind of like dissolving oxygen in water. And this is what fish actually breathe through their gills. They don't break down water into hydrogen and oxygen. They pull out dissolved oxygen from the oxygen-water solution. Isn't that cool how God made fish and they can just use their gills and pull out the water? Kind of neat. This is also why if you have a fish tank, you put a little bubbler in your fish tank because it helps stir the water around and adds oxygen to the water so that the fish can have enough oxygen to breathe. Because if fish are in a tank, over time, they're going to use up all the oxygen that's currently in the water, and they would technically suffocate if they didn't have a little bubbler. So there you go. So remember that I said density will create water currents. Well, density can happen in a couple of different ways. It can happen due to the increase in substances in the water like salts or sediments, but density can also happen with an increase or decrease in temperature. When you increase the temperature, you decrease the density because the water molecules move further apart, just like air. And when you decrease the temperature of water, you increase the density because the water molecules get closer together, just like air. And so increasing and decreasing the density with temperature will cause the water to move and create currents as well. So this lab demonstrates both temperature and salinity currents. The red is hot water with low density or low salinity, and the green is cold water with high salinity or high density. And the blue that's introduced a little bit later in the lab that you will see is halfway in between the red and the green as far as temperature and density goes. So notice how each layers act depending upon their temperature and their density, and notice that through this lab, those layers don't actually mix. Really cool. Okay, this lab demonstrates both temperature This experiment is very similar, but just looks a little at density and salinity.
We will do a simple experiment to see the effect of salt and the density of the water. But first, we will define what is salinity. Salinity is the ratio of dissolved ions in the mass of seawater. Now, we have three cups. Cup A that contains clear tap water. Cup B that is red in color contains 2 tablespoons of salt. And cup C that is in blue water contains 5 tablespoons of salt. First thing we need to do to start the experiment is to pour this red water to cup A with clear tap water and see the result. As you can see, two layers were formed. The water that contains salt had shrunk to the bottom. So we can say that salt water is more heavier than clear tap water. As the experiment goes, let's pour this cup C that contains blue water to cup A and see what will happen. We can now see 1, 2, 3 layers in cup A because cup C contains more salt, thus making it more dense than cup B. In a nutshell, salinity affects the density of the water. The increase in the salt content is also an increase in density of the water. So that's all, and thank you for watching. We will do a simple
And again, then this last experiment looks at salinity densities. So watch how a density wave is created using these 3 videos that you just watched as one complete lab.
I'm going to remove the
I want
plastic
you to do
divider
a
and
lab
see what
write-up
happens.
over your observation of these 3 labs. So you're only writing one lab write-up. Take that and put it in your ISN when you finish.
The denser blue water quickly flows under the less dense yellow water. Then we get an internal wave sloshing back and forth. You can see the surface is calm, but internally between the two different densities, we get a wave that sloshes back and forth. And we get the divider. Separate the two sides again. We can mix one side, and see what the intermediate density water does. We can see that it forms an intermediate layer between the densest blue water on the bottom and the less dense yellow.
Layers may also be mixed by tidal mixing over a shallow shelf.
And we can put our finger in slowly, and we feel the very warm water on the top and the much cooler water on the bottom with our finger. Very easy to feel the difference.